Right, good morning. Today what we're going to do is a kind of a tutorial, in the sense that from the exercise you wrote yesterday, which I was to write yesterday, I observed something and I noted what exactly maybe I should put straight here. So I'm going to go through, just highlight what have we done, and then from there we can see where we are now and maybe how we should work, especially the difference between the definition of a derivative and the use of a rule like power rule for differentiation. You can't always go back to the what after using the definition of derivative to derive the power rule. You don't always go back to the definition and use the limit. No, we just use the power rule as observed as a conclusion of that process of using the definition. Am I making myself clear? Okay, so now let's get to particular exercises and see what we can do. Now, but before we get to a particular exercise, let's say this is a tutorial now. No picture showing. I was saying this is a tutorial. So let's start from the definition itself. That's to remember we said we're going to define the derivative of a function at a generic point x by the limit. We said limit delta x going to 0 of f of x. Oh, sorry. F of x plus delta x minus f of x over delta x. Please guys, listen to me very, very carefully. There's no way we can calculate each and every derivative of a function via this. This is the definition. All together. So this is the definition. So after a number of examples doing exactly this with functions with this kind of terms, let's say powers of n, using this, we discussed this and they arrived at the point that this process, actually this definition process here, using this will lend us at a derivative which looks exactly like this. Does everybody understand that? Do you see that? We use this definition and we arrived at that. Now then, tomorrow or today and every day, unless if somebody asks you to use the definition, if I'm given here y is equals to x to the power 4, maybe multiplied by 6 somewhere there, I have to differentiate. We know that if we're differentiating a function multiplied by a constant, the derivative will be that same constant multiplying the derivative of the function, isn't it? So we can say here the function is x power 4, the constant multiplying the function is 6. So we're going to differentiate x power 4 using exactly the power rule. I'm not going to do this. All together. So then we can say now this prime is equal to 6 brackets. In the brackets, I'm going first of all to work out the derivative. I don't want to mix things, especially when you are starting at the beginning. You work slowly until you sort of feel comfortable, then you can work faster and faster. So slowly it will say 4x4 minus 1. Then I'm saying that I'm using exactly that rule there. We call this power rule. All together. So the derivative is just simple, ends up in 6 times 4 times x to the power 3. what you've done, you are doing now is just simplification, which has nothing to do with differentiation. Then you can just write here 24 x to the power 3. Are we together, guys? Okay. Same thing. We looked at trigonometric functions like cosine. We put cosine through this definition. We did do the definition, and we arrived at the fact that when we differentiate cosine, we're going to get here y prime is equal to what? Minus sine. Minus sine x. Now, like I was saying before, you cannot now go every day when you see cosine, you do this. You not finish any test or any written exercise within given state time. If I give you 5 minutes or 2 minutes to do this, or even 1 minute to do this, and if you go through this, you are not going to do that. But this process, why did we begin there? We begin there so that you can understand the concept of a derivative as a limit of this incremental quotient. Because derivative is a limit. Are we together? You understand what I'm saying? Okay. So now, then let's get to a situation now where we get y cosine x squared. You differentiate, like I said, when you're applying the chain rule, you've got now, you can see that now we've got two functions there, cosine acting on a parabola, then you must apply the chain rule. Don't that route there, via the definition. I'm cancelling it at this stage. Are we together? Yeah. So don't go this way. Just go direct this way. Call upon the immediate derivative of what? Of cosine. Then, as the chain rule says, you must multiply by the derivative of the argument. Then you can come here and say, okay, this is minus sine. Retain your argument, which is that, and then multiply by the derivative of argument. As you can see, derivative of argument is this kind of entity. Then you apply that power rule there. Then you just write 2x to the power 2 minus 1. I'm writing that 2 minus 1. Somebody might say, no, I know this thing, I don't need that. But then somebody there is slow with whatever. We've got to write it explicit there. Then what you do now, we rearrange this. You get your 2, your minus 2 minus 2x sine x squared. Now, in your book, or in any other book, I think I would actually encourage you to look at more than one book. You will find that after doing this deriving 1 or 2, 3 derivatives using the definition, what they do is they give you a table of derivatives. Are we together? There's no lecturer you're going to find who's going to derive each and every derivative from the definition and then say, then from there learn it. That is that. No. You find a table of derivatives. What is there now for you is to learn the table of derivatives. You know, so I don't know whether you're saying you know this from memory or what. I think from differentiating 2 days, 3 days, cos to minus sine, cos to minus sine, you end up knowing that is that. So from there now, you can actually operate from memory, from knowing that the derivative of tan is sec squared. The derivative of cos is minus sine. The derivative of sine is cos. That one, from now onwards, you must know. But the basic principle you mustn't forget is the principle of using, especially the chain rule, that you always differentiate the leading function and you must multiply by the derivative of the argument. All together? Like for example, I've just said here, if you've got tan x, the derivative is I said it is sec squared x. But somebody might say, now where did you get this thing? Or maybe, how do I know that this is exactly the thing? if you try to use the definition with tan here, I'm very sure you might spend the 2 days before you get to the limit correctly. But we know the quotient rule now. We know the product rule. Let's put that down. We know the quotient rule. If we're differentiating a product of two functions, I'll just write the D for differentiating. Then this will be the same thing as dv multiplied by u plus v multiplied by du. There I'm just saying derivative of v multiplied by u plus the v multiplied by derivative of u. In other words, you look for derivative of each of the functions and then combine for the product, the derivative product, you combine those functions this way. If you look here, you've got the two functions u and v, you've got the derivative of two functions du, dv, but you combine them this way. Then we've got derivative of u over v. We've got the derivative of u over v. This is a quotient. We discussed this thing, arrived at the point that this will be v squared du multiplied by v minus u multiplied by dv. That is very important. Then in addition to chain rule and this, you must be able to differentiate now anything. Now let's say I had forgotten this, and I don't have a table maybe which is going to do it. Let's say I've forgotten this. But what do I know? I know that tan is equals to sine x over cosine x. Then they say, fortunately, I remember the derivative of sine and the cosine. Now it's the derivative of sine and the derivative of cosine. So then I can apply this. Let's apply this. What I'm going to do, we're going to say derivative of tan x, which is the derivative of sine x over cosine x. What is this? Applying this the quotient rule, I will need the derivative of sine. What's the derivative of sine? So that's cos x multiplied by the denominator, which is cos. So cos x minus multiplied by the sine x. In this case, sine x, the numerator. Is it right? I'm here. Are we there? Then multiply by the derivative of denominator. Derivative of denominator is minus sine. All together. Then divided by cos squared. So then if you look at what we've got here, this is minus times minus the plus. So which means we've got cosine squared x plus sine squared x all over cosine squared x. Am I making myself clear, guys? Okay. So then from there, like I told you before, that at school you hated these trig identities. I think you must start making peace with them. Because now if you've gotten this trig identity, you cannot proceed to where you want. So then what we get there? This is 1. This is the Pythagorean identity, isn't it? This is 1, and this is cos x all squared. It's the same thing. Whether I write cos squared in the denominator or I write 1 over cos squared, that is same thing. Then again, this is an identity. What is this? That's sec, isn't it? So that's identically equal to sec then which means now this comes as the sec squared x. So this is what I said there on the table. That's what you're going to get there. But then this, what I'm trying to discuss here, if you know the basic the derivatives like sine, cos, some of these you can derive them. And from here now, you can actually try to use exactly the same kind of approach here to derive what is the derivative of cot. So what do you do? Doing these things, applying these properties, applying these rules, what you do, you end up actually having a complete, you can actually make your own table of derivatives if you want. But maybe that's not necessary. It's there in books, you go on and do those things. So as you can see, guys, I've done this problem. I haven't gone to the incremental quotient. I haven't used the word limit. Whatever I used, I've used the rules I've learned, and I'm exploiting them to actually explore what I don't know. Are we getting that clear? Okay. So now let's come to another problem here. Now I'm looking at your compilation of exercises there. These exercises, I think they're from page 275 to 276 of your text. So one exercise there says y equals to cosine pi plus x squared plus x cubed minus 2x. That's the derivative. Then let's come and calculate dy dx. Now, I've given you enough time to think about this. Can you now tell me what is derivative here? Tell me, there are 1, 2, 3, 4. Applying that principle that if I'm differentiating two functions, the derivative is sum of two functions. So if I'm differentiating 6, the derivative is sum of this derivative of individual 6 derivatives. I think. Yes or no? Okay. Yes, tell. Minus sin pi plus
x to the power 2 minus 1. Or should I just say x?
What should I write?
X.
X
Plus 2x to the power 2.
Plus 2x to the power 2 minus 2. I don't know what's happening here. Let's just get, I think all of us have got to have this in mind, and then have this in mind, that the derivative of that is x n power 1, and then have in mind the derivative of sine and cos. So, okay, actually let me tell you something. All what you've written here does not make sense to anyone. So, right, correct the mistake. Correct the mistake. Let me correct the mistake.
It's minus sine pi.
Minus sine pi
Plus 2x.
Plus 2x to the power 2 minus 1. I told you, let's show the steps so you can see what they're doing. Yes?
Plus 3x.
Plus 3x
To the power 3 minus 1.
to the power 3 minus 1
Is minus 2.
minus 2. Now simplify that.
Minus sine pi.
Minus sine pi
Plus 2x.
plus 2x
Plus 3x.
plus 3x to the power 2 minus 2. Right. Listen to what I'm saying. I'm now going to ask your colleague to mark this exercise. Yes, Zita, mark this. If it's fine, just say 100%. If there's something you want to correct, say, I want to correct this. 100%. Zeta and the stolen say this is 100% correct. Yes? 100%. My sister at the end there? You agree? Okay? Yes? You don't agree? How many people don't agree? Let's see those who don't agree. No. You listen. I gave you 1 minute first to think about this exercise. I said when I call upon to you, you must differentiate and differentiate correctly. Okay, listen. Your time is over. I'm not talking to those people who are saying it's not correct. Right? Who can explain what is not correct?
The negative sign pi could be 0.
No. Not could be. Must be 0. This is not a function. This is a constant. Cos of pi is -1. So we are differentiating a constant here -1. The derivative must be 0. All together. So derivative must be 0. What is the problem? This guy, when I gave him a minute to think about what he has before him, he didn't look at each and every term and answer himself a question. Here, I've got a power function. Here, I've got a constant. There, I've got a linear function -2x. You didn't answer those questions. So, I'm not trying to be funny. I'm just trying to say, when you get this thing, I think apply yourself more, because at the moment, you're overlooking some things. That's all right. So the answer is going to be 2x plus 3x squared minus 2. Agreed? Okay. Zeta, I think you are covered now. Yeah. Okay. Any questions? Any clarifications? As you can see, I didn't use the quotient, the incremental quotient calculating limit somewhere. I'm just using the knowledge of the standard derivatives and some rules and all those things. All together? Okay. Now let's come to this one. Let's say we're given, let's mark this as exercise number what? Is it exercise number 2 or what? Let's see what we had here. Or this was just an explanation, introduction. So let's get this as number 1 for our tutorial. Let's get a number 2. The exercise is y equals to e to the power tan of x squared multiplied by sec squared x. Already, this is how I compile my, if you're going to do a piece of work, I don't know what you're doing, whether you're painting or you're doing what do? You have to collect the tools you need, isn't it? Is that not, that's normal, isn't it? So once I know the task I'm going to do, I need to collect the tools I need. First, I see that there's a composite of 2 functions here. I'm going to say here, chain rule is called for. I'm seeing a product of E and the sec. But I'm saying a product of E and sec, I'm actually seeing a product of E and the square. Because this is a square function. Let's write it this way, this way. We can write this thing this way. I see a square multiplied by an exponential function. So which means the product rule will be called for. Then I see a power here. When I'm going to differentiate this argument, because remember, I can see this as an argument of a function, so I apply my chain rule, says I differentiate the leading function multiplied by the derivative argument. So when I come here, I can see power rule is going to be applied. What am I doing at the moment? I'm not doing the exercise for you. I'm trying to apprentice you in your approach. Don't just get into the thing which you don't know what it is. Which you don't know. You should first of all do some analysis. Now break down the exercises into small pieces, which you can know that this piece I'm going to deal with this way, this piece I'm going to deal with that way. The whole piece is going to be dealt with this way. Are we together, guys? So now, product rule, I think everybody knows. I don't need to rewrite it down. If you read, you really need to be written down. There it is. There is the product rule. The chain rule says there's a composite of two functions. What do? You just differentiate the leading function multiplied by the derivative of the function which is being acted upon until you get to the simplest argument where you are like differentiating dx, and you don't even write that. Right. Guys, do it. Do it. I've shown you how the analysis, which you must do to in the next exercise. At the moment, do it and give me the correct answer. Okay, right. Let's clarify something here. Let's clarify something. If I write something like this, A, B, all squared, this square affects A and the B. But if I write A, B squared, A is not squared. It's only B. So now if I write, so this will come out as A squared, B squared, as we all know. This will always be like this. Now, if now I've got tan squared. You see this tan? This square is affecting tan. It's not affecting the square, the x. But if I write now tan x squared, this square is just affecting x, not tan. This I can rewrite as tan x. This one cannot be taken to that form. Are we together? Okay. So please be careful when you're dealing with that there. The gentleman there is ready to give us the first step. Okay, what can we write there? Yes, equals tan x squared. Tan x squared multiplied by e. Yes. 2 sec squared x squared multiplied by sec squared x plus e tan x squared sec x tan x, sec x tan x. Okay, who has got a comment? Let's leave this exercise, this solution as it is there. I'm not saying it's wrong or what, but for me, listen to me, if you don't understand me very badly, I want a student to show me his mistake to the fullest. That's why I'm not making a comment. Then when the student has shown me his mistake to the fullest, I think I'll be able to know exactly where the problem is, and I'll be able to point exactly whether the problem, where the problem is. If anyone wants to comment on this, whether it's correct or wrong, they've got a better suggestion, something like that. Not that it's wrong for him to be wrong. It's correct for him to be wrong, because this is the learning process, isn't it? So from here, you hit against the wall, you know there's a wall. Are we together? Okay. Yes. Does anyone want to suggest something? Yes? No. Give me your solution. Your solution.
My solution.
Yeah.
My solution is the derivative
dy dx.
dy dx
Yes.
equals
E.
step or the
Yeah, just give me the first step. I think you most wanted to give me the first step. Yeah.
equals
E
E 10 to the power 10
E tan
x squared
x squared
times
times
sec squared x,
sec squared x x
x, yeah,
yes
times 2x,
times 2x
then times in brackets the sec x
the sec x all squared,
squared, yeah,
yes,
plus
plus
e tan x
E tan x
squared
squared
times
times
2 sec x
2 sec x.
times in
Do you
brackets,
want to say here 2 minus 1?
yeah,
Okay?
okay, and then in the brackets
Yeah.
that it is sec x tan x.
Sec x tan x. Sec x tan x. Why is he saying his answer there? I would invite you to try to say, why is he saying sec x tan x? Why is he having this? Why is he having that? And why is he having sec x? Why is he having here 2x? And why is he having that? One of the things, I think he's having this because of the product rule. He has get this sum, and this again because of product rule, and something like that. But there are some things which I don't want to justify for you. I want you to justify for me. Who agrees with this? You agree with that? Okay? Yes, this side, what do you say? Do you agree or don't have an opinion? Yeah. If your answer is different from this one, you don't agree. Do you agree with this one or don't agree? We've got a different answer. Talk to me, my friend. There are two things. It's either agree with this one or we've got a different answer. No, listen. I didn't say mark this. I said, do you have a different answer? We've got a different answer. Give me your answer. Give me your answer. Just let's hold on a bit. dy dx. Come on. E to the power tan x squared times 2x times 2x times sec x times sec x squared. What are you saying? What are you saying? Times sec x squared. Okay? Times sec x squared times another sec x squared.
Times sec square x.
I don't understand.
Times sec x. Sec square x.
Sec squared x. Okay?
Plus
Plus 2 bracket
sec x.
sec x close bracket to the power of 1 times sec x tan x. Yes. Finished. Right. Do you agree with this? Who agrees with that? Nobody. I don't agree with everything. Okay. No. Listen, this is not funny. It's just try to highlight mistakes. That's right. It's so that really you see where what. Yes. Where last time you forgot what? What did you forget? Right? Ethan.
e to the power of tan x squared.
It's okay. E to the power tan x squared. Okay. Right. Yeah. Then I was really worried about that one, but still I don't agree. Okay. What has gone wrong? What has gone wrong? First of all, let's check. The function we're differentiating is an exponential function that here, and we're differentiating sec. First thing, we know we're going to you apply the chain rule, we know we're going to apply the product rule. But the first thing with exponential functions, my friend, whenever you differentiate an exponential function, it comes back exactly as it is in the derivative. So this is correct. And then this is wrong. The exponential function will come back exactly with its same argument. It doesn't change the argument because it's differentiated. Make that clear. Take a note there. All together, my friend. Okay. So that is correct. Let's go further. We suppose that this guy now is applying the product rule. Maybe let's write the product rule here so that you can see it. Derivative of u v equals to derivative of u multiplied by v plus u multiplied by derivative of v. Is that right? Okay. So I think at the moment here, this guy, if we call the first function here u, this guy is differentiating u. He's trying to differentiate u. Okay, let's see. The exponential function comes back, okay, correct, multiplied by the derivative of the argument. The argument of e is sec. So the derivative will be sec squared. So this is correct. Let's see what's happening here. This is correct. This is not correct. Because I suppose that this sec squared here is coming from the function, which is this one. So this one, this part here, must stand as a derivative of the argument of this function, which is not correct. I understand what I'm saying? Okay, let's come here. The derivative of tan as an argument of e is sec squared. But this is wrong. The argument cannot change because the function is differentiated. That's right. So that part is wrong. Do you see what is wrong? Okay. Then after that, the argument of tan is squared. The derivative of the argument is that. This is correct. Then multiplied by v. This is correct as a derivative of v. I'm not saying I'm going to give marks that way. I'm just pointing out what so far is correct, what so far has gone wrong. So that 2 there, which was lost there, that went wrong there. So let's maybe put a wrong there, for something went wrong there. Are we there, guys? Okay. Then, at the moment, this function is multiplying as v without differentiating it. What happened here? You can see what we don't have here. Check your work, my friend. Check your work. What happened here? You can see what you are missing here. All what I've said is correct. This side is no longer there. This function is there as multiplying the derivative, but the derivative we are getting here is not correct. Are we there? Come this side. Also, I think you have seen what is the difference. Isn't it? Okay. Are we there? Correct for this part. Now, we come to the next part here. This says u without differentiating. U. This would be correct, I think. That's u. and this will be correct, that's u. Now we need the derivative of sec squared, but that's a power function. This is correct. But the argument of the power is sec. So when you differentiate the argument of power, you get sec tan. So this is correct. Let's come here. Here, the power was lost. This part was lost. We only have the derivative of the argument there. But the power function, that 2 minus 1, where here we've got sec, was lost. And then come here. This is correct. This and this is exactly the same thing. All together. Then this is a derivative, as a power, as a base of 2, a function, its derivative as an argument of the power function. This one is correct. This is exactly the same thing like that. And this one is the function, is exactly the same thing like that. Are we together, guys? Are we together? Okay, so let's do it correctly together once. Right. We would have said, I'm basically rewriting the correct answers correctly. We would have said the function is e tan x squared multiplied by sec squared x. So differentiating, applying the power rule, the product rule, I would have said, maybe you might not write this thing this way. Our first thing would say d e tan x squared multiplied by sec squared x plus e tan x squared d sec squared x. That took my first step if I'm doing this thing for the first time. I'm trying to be very careful. Are we together? Okay? Then the next thing, I know the derivative exponential function bounces back exactly as it is with its argument in the derivative. So this will come exactly as tan x squared multiplied by the derivative argument. The argument of exponential is tan. So sec squared x squared. But the tan is acting on a function, so that the argument is going to be differentiated. So multiplied by 2x multiplied by sec squared x. Am I correct? Just check if there's a slip of a pen somewhere. So plus e tan x squared. Then I come and differentiate here. I'm power rule sec 2 minus 1 of x. Argument of power sec derivative sec x tan x. I'm done. All what I'm left with is just to reorganize this thing to look more compact, maybe more beautifully presented, simplify where they are like terms. You can see this is sec squared x squared and this is sec squared x. You cannot combine the two. They are going to remain as they are, isn't it? So I've got 2x here. So I'm going to have a 2x sec squared x, then sec squared x squared. E tan x squared plus, here, check this one. You've got sec here, x. You've got sec here, x. So these two can combine to sec squared, x. So 2 sec squared x multiplied by tan x e to the power tan x. Then I can hand in my exercise. Maybe the other thing you can do if you want here, just check here. These two. You can write sec x sec x squared and put them in a bracket as squared. Applying rules of exponent, you get to that, isn't it? But you cannot have one sec because the arguments are different. Okay, guys, is that helping or what?
Yes.
Is that helping? Okay. I know students are very, I don't know what happens to people when they're students. They are very, very, very afraid to ask. You've got to ask for them.
You went back a bit
Way back
to the last thing.
to the last part. Please don't just copy it. Understand it. Is that right? Yeah.
So,
Yes?
there where the multiplication it goes in with the 2 sec squared x multiplied with the sec x tan x.
Mm-hmm.
There is not a multiplication sign between the sec x and the tan x, right?
There is. I used the dot there. There is.
There at the end.
Where? Here.
Yeah, at the end, yeah.
Here.
Just go one step up.
There's a multiplication sign here. There's a multiplication sign there.
Just go one step up.
Am I right? Just check. Yeah, this is 10. Yeah. One step up, yes?
Because if you multiply in 1, 2 and multiply in with the sec x there and then the tan x at the end as well.
So there are three factors here. If I simplify this, this is sec x, this is 2 times sec times tan.
Times tan.
Yeah,
Okay.
yeah. What is your question?
No, I was just making sure that you shouldn't multiply in there and then just the tan as you multiply actually with the whole bracket.
Yeah,
If there was a plus in there, you
oh, no, there's no plus there. This is a tan. This is a tan.
no,
Yeah, okay.
That's
Okay.
a mistake I made.
Okay, all right. Correct that one. Are we fine, guys? Okay. Please listen. I'm not going to delay my time for copying this thing because I'm going to give you this video clip altogether. Yeah. You must have listened careful when you're doing this thing. Then follow up that. Yeah. Let's come to something. I want to look at something now, which is a bit. Now let's look at the exercise number 3, which is y equals to e 6x squared plus 5x ln x cubed. Right. 1 minute to think about that. Right. I think 1 minute is gone, and it's actually more than 1 minute. Tell me, let's have somebody doing this kind of analysis. This one. This one. Collect your tools. Tell me what tools you've collected here. I'm just thinking. Yes, who is ready to do that? Yes?
Okay. Do you do the first step or the...
No. I want these things first. This kind of the things you're involved, which you think you're going to have there, to deal with there. Tell me, what do you have there?
You'll use chain rule.
Chain rule will come in.
And you'll use the product rule.
Product rule will come in.
And the power.
The power rule will come in. And everyone must be able to identify now where. All together. In addition to that, I must know the standard derivative of an exponential function. Remember, after discussing the exponential function natural base, we also looked at the exponential function any base. We said any function exponential x to the power f of x, it differentiated to exactly the same exponential function multiplied by the derivative of the argument multiplied by the ln of the base. All together. And then this also, if the e is natural exponent, e, then ln of the base is 1. Then we don't see that. So we need to know also the standard exponential kind of differentiation. And secondly, we need to know the standard derivative of a ln function. You see what I'm saying? Then the derivative of ln function is as simple as 1 over the argument, whichever argument. Let me actually write here f of x, ln of f of x. So then the derivative is 1 over the argument, whatever the argument is, multiplied by the derivative of the argument. All together. In that thing, all that what I'm saying there, guys, it must happen within a fraction of a minute or so when you're looking at the exercise. Because remember, you don't have years to write a test. You have minutes to write the test. And you can start having minutes, and then remember, minutes will turn to seconds. You can have hours, and hours will shorten to minutes, and minutes will turn to seconds, and seconds will turn to 0 seconds. You end in. So this must happen in a fraction of a minute. So now, let's have our sister there giving us her suggestion. At the corner there. Give us your first suggestion for this, just like the other guys did before. Yes. E power 6x plus 5 plus 5 or plus 5x? Plus 5x multiplied by 12x to the power 2 minus 1 plus 5. Let's put this in brackets. You must be very careful. Use of brackets. All together. If you don't use brackets there, then you got total different and then correct thing. Yes? By multiplied by ln x cubed plus e to the power 6 x squared plus 5x multiplied by 1 over x cubed multiplied by 3x 3 minus 1. 100% correct. I'm not going to waste time there. 100% correct. Thank you. Thank you. Please, the only way you are going to remember this is to repeat again and again. All together. And from there, you must... All together, guys. That's just a question of principle. Practice makes perfect. That's what it says. That's what English says. But us, we don't say that. So, what remains there is just simplification, writing this nicely, and giving out a presentable answer. What's going to be left here? This will be x power 2, and this is x power 3. We're going to be left with 1 over x. Do you see that? So we're left here with the e6x squared plus 5x over x. I didn't check with you. Was I right to say it's 100% correct? Yes, guys. Yeah? Okay. Oh, if it's fine, it's fine. If we agree, all of us, then it should be correct. Then this is 12x plus 5. Right here, 12x plus 5. Carefully, please. Brackets, you can't leave brackets there. Ln x cubed multiplied by e 6x squared plus 5x. And if it's not very, very clear whether this ln can be confused as an argument of this e can be confused.
So no,
There's a mistake.
yeah, at the end there with the e to the power of 6x, we forgot 3. There's 3x squared over x to the power of 3. So if you cancel out
The 3.
Yeah.
This 3, sorry. All right. That's 3. Okay, thank you. And then I was saying that if you think you're going to confuse the argument of ln here, you can actually even also put brackets around that one. All together? Yeah. Or reorganize it, write the term in a different order, which does not suggest some kind of confusion with the argument of ln. That will be fine. I'm happy with that one. It was well done. Thank you, my sister. Can we move forward? Can we move forward? Okay. What time is left for us? Check that.
It's 13 minutes.
13 minutes. Ah, no, that's a lot. Right. Let's have, this is exercise number 4, I think, is it? This is y equals to cos t over 3 plus the square root of sine 4t. Come, Peter, let's get your first suggestion. What are you going to say?
First step.
Yeah.
Minus sign.
Is it minus sign equal to the desk or is equal to the laptop?
Oh, the derivative of cos t over 3.
No. Here we've got a function y.
Y prime
Y prime, I want to use it to do that dy.
dx.
Dy?
Dx.
Are you sure?
dy dt.
Oh, okay. So that's another important thing. Don't be given a function in terms of t and a differential in terms of x, because you differentiated a lot of functions in terms of x before. Okay, now we're talking.
Minus
Minus
sine
sine
t over 3
t over 3
multiplied by the derivative of t over 3.
multiplied by the derivative with respect to t of t over 3. Okay?
Multiplied by the square root of sine.
Multiplied by. Y.
Plus sine 4t bracket sine 4t inside.
Sine 14 brackets, yes.
Then to the power 1 over 2.
Power 1 over 2. Multiplied by
cos 4t
cos 4t multiplied by 4. Don't want to look at this again, just especially this part. A second.
It's going to be half
Where half?
in front of the
before the bracket. Yes. Minus 1. Good. Let's say 2 over 2 wants to make it easier to subtract, isn't it? Okay. That looks correct. Is that right? But we still need something here. The next step, what is the next step now? That's the first step, is fine. But we still need to simplify here. What would be the situation? You know what he said? I don't know. I don't think you heard him. When I said, what did you say here? He said, yes. Normally, I think that is a sign of having some kind of stress. What is the stress about, my friend? The derivative of t over 3. It's very difficult, eh? Try this one. The derivative of 2t. What about the derivative of half t? It's half. Isn't it t over 3 equals to 1/3 t? Huh? So your eyesight is not very good, my friend. That's a problem for eyesight, isn't it? So when you're having this thing, it's exactly, we've got mt, 2t, 8t. Is that right? Good. So what are we going to have now? Minus sine over t over 3 yeah, plus this will be minus half, minus half, minus half. So we're going to have here half sine 4t to the power minus half is 1 minus 2. Answer is minus 1. So multiply by 4. That 4 we can multiply it with it here, isn't it? So it is 4 over 2 cos 4t. We can still make this look nicer than this, isn't it? So this is a 2. This is a power half. We can still use that export, that thing which says x to the power minus n equals to 1 over x to the power n, where our n in this case is half. But a half changes to a radical sign, isn't it? So which means if the radical sign way in the denominator. Do you see that? Yes. So then we can write this nicely as minus sine all over 3 plus 2 cos 4t over a beautiful square root of sine 4t. I hope you have appreciated how it has helped you to do this exercise yourself, isn't it? So please, can you take it as a kickstart to go and do the rest? More and more. Follow the slogan. Do it. Yeah. Right. So I think this is time to call it an end of a good discussion. I hope it helped, but it's not going to help if you don't do anything yourselves. So thank you for listening.